Welcome to today's lesson on physical properties. You'll need a copy of your physical properties guided notes. Your success criteria for today's lesson is describe the physical properties of matter, how properties are used to choose materials, methods used to separate mixtures, and evidence that indicates a physical change. You'll also be able to identify substances based on their physical properties. The vocabulary you'll need to know is physical property, viscosity, conductivity, malleability, melting point, boiling point, filtration, distillation, and physical change. Let's talk about examples of physical properties. A physical property is any characteristic of a material that can be observed or measured without changing the composition of the substances in the material. Viscosity, conductivity, malleability, hardness, melting point, boiling point, and density are examples of physical properties. Think about spilling a glass of milk. Then think about knocking over a bottle of maple syrup. You should notice that the milk gets all over the place really quickly and you have much more time to pick up the syrup before it makes a huge mess. This is because of the viscosity of different liquids. Viscosity is the resistance to flowing, the tendency from a liquid to keep from flowing. Viscosity of a liquid usually decreases when it is heated up. Have you ever been to a restaurant where they serve warm syrup? This property is important. Motor oil is used to keep the engine parts from wearing down. This is why proper oil and frequent changes are needed to give the engine the longest life possible. What kind of spoon would you use to stir a pot of chili cooking on the stove? I would use a wooden one or a nylon one personally. Think about stirring a pot of chili or soup with a metal spoon. It gets hot and even the handle gets hot. But wood spoons won't. They stay fairly cool to the touch. This is because wood and plastic are poor conductors of heat, whereas metal is a great conductor. Conductivity is the material's ability to allow heat to flow. Good conductors of heat are usually good conductors of electricity as well. Blacksmiths will use a hammer and punches to make a piece of metal in the shape they desire. Ancient blacksmiths would use hammers and punches to make gold medallions and other metallic items. Blacksmiths use a physical property known as malleability, which is the ability of a solid to be hammered without shattering. Some materials cannot be hammered, like ice for example. In this picture here of a soccer ball going through a glass. Instead, these are shattered when they are struck. These objects are considered brittle. One way to compare the hardness of two materials is to see which material can scratch the other. A typical blade of a kitchen knife can cut through a copper sheet because the stainless steel is harder than copper. Hardness is how easily an object can be scratched. In earth science, Mohs hardness scale is used to determine the hardness of minerals. A German geologist, Friedrich Mohs, developed a scale in which an unknown mineral's hardness can be compared to the mineral hardness of 10 minerals, with talc being the softest and can be scratched by a fingernail, and diamond, which is the hardest mineral. This is one of the most reliable tests for mineral identification. Diamonds are the hardest material on the scale and has many uses, as you will find diamond-tipped drill bits. There may be pieces of diamond in grinding wheel to sharpen stainless steel blades. If you leave a tray of ice cubes on the kitchen counter, the ice cubes will begin to melt. Melting point is the temperature at which a substance changes from a solid to a liquid. The temperature where ice typically begins to melt is at 0 degrees Celsius, turning into a liquid form of water. If you put water in a pot to make some spaghetti noodles, you may boil the water to cook them. Boiling point is the temperature at which a substance changes from a liquid to a gas. For water, the boiling point is around 100 degrees Celsius, which at this point you start to get water vapor or steam, the gaseous form of water. Pictured is a table of some of the melting and boiling points. Density is the ratio of mass to a substance to its volume. Density can be used to test the purity of a substance. A Greek mathematician named Archimedes is said to have discovered density when his friend King Hiram II asked him to see if the goldsmith was using pure gold or mixing it with silver to keep some of the gold for himself. The American Motorcycle Association will test the density of the fuel to make sure that it's close to pure within a certain range to see if there were no additives added that could give a rider an unfair advantage. Precious metals can be tested by using density that will not damage the metal in any way. This is an easy way to test the differences between gold and pyrite. Concept check number 1. List 7 examples of physical properties. Question 2. Explain why sharpening a pencil is a physical property. This would be a good time to stop the video, answer the questions, and then resume for the answers. Question 1. List 7 examples of physical properties. Hardness, viscosity, conductivity, density, malleability, melting point, boiling point. Other examples could be color, taste, flexibility, durability. Question 2. Explain why sharpening a pencil is a physical property. The shape and size of a pencil change, but the composition of the pencil remains the same. Let's talk about how we can use these physical properties. We can use them to identify material, choose a material for a specific purpose, or separate substances into mixtures. Using properties to identify materials. The steps involved in identifying materials is very basic. Decide which properties to test, do tests on unknown material, compare the results to unknown materials. Forensic scientists use this method for solving crimes on many unknown materials. The identification of a material can be a crucial step in solving a crime. Detective collects red paint chips from a scene of the crime of a hit-and-run accident. Then asks the chemist to identify the paint used and compare it to a database to find out which of the vehicles had used that specific paint. Then the detective can use this information to narrow down a search of people that own that type of vehicle. Properties determine what materials are chosen for which uses. For example, you wouldn't want to use a shoelace that are made out of wood or tires that are made out of stainless steel. People don't consider just one property. Some materials might work for certain properties, but compared to others, might not be the best choice. You can also use the properties to separate mixtures. Filtration and distillation are two common separation methods. Filtration is the process that separates materials based on the size of their particles. One of my favorite uses of filtration is making coffee. You may already be familiar with this process. Hot water is mixed with coffee grounds, where the coloring and caffeine are diluted into the water. Then the coffee filter stops the grounds from going into the pot, but allows the life-saving deliciousness to flow through. Because who wants to chew their coffee? That's gross. With COVID hitting, we were all required to wear a mask. The purpose of the mask was to filter air to protect ourselves and others around us. Face masks are also used to filter out different particles in the air. For example, it would be used them in woodworking to keep from breathing in all the dust. Contractors use it when they're installing insulation in the attic to protect their lungs and breathing airways. Distillation is the process of separating the substances in a solution based on their boiling points. One practical use of distillation is to provide fresh water from salt water. Submarines use this process along with desalination water plants. They take salt water from the ocean, distill it to get fresh water to drink. The picture here shows a basic setup of saltwater distillation into fresh water. The salt water is heated up and the water boils. The salt is so heavy that it stays behind and the water vapor is transferred, cooled, and then collected as water that is safe to drink. A physical change occurs when some of the properties of the material change, but the substance in the material remains the same. The butter shown here is heated up and is melting, but it is just liquid butter. Melting an ice cube leaves water. Boiling water turns it into water vapor. Cutting into a watermelon into a smaller piece just changes the shape. In these examples, the shape and the state change, but the chemical compositions are still the same. Some changes can be reversed. Melting ice cubes can be refrozen. Butter will solidify when it cools. You can tie a shoelace, untie it, and tie it again. Some changes cannot be reversed. Cutting a piece of wood Measure twice, but cut once. Sharpening a pencil. A tomato can't be fused back together once it's all been sliced. Concept check number 2. Question 1. Describe 3 uses of physical properties. 2. What are 2 processes used to separate mixtures? And 3. What allows a mixture to be separated by distillation? Again, this would be a good time to pause the video, record your answers, and then check your answers after. Question 1. Describe 3 uses for physical properties. Identify materials, choose a material for a specific purpose, or separate substances into a mixture. What two processes use separate mixtures? Filtration and distillation. What allows a mixture to be separated by distillation? A difference in boiling points allows mixtures to be separated by heat.